We live. We're gonna design a bunch of Facebook services. We're gonna first design Facebook newsfeed. Then we're gonna hop into designing Facebook Messenger, and then finally we're gonna top that off with designing Facebook live streams. So yeah, that's pretty much what we're gonna do. All following basically this hello interview stuff. So design WhatsApp is gonna be similar to Messenger, so I'm just gonna go with that. But we're gonna start first with designing a Facebook newsfeed, and we're gonna pretty much compare it to what the notes are here. Wow, this is a hard question. We're gonna figure it out. Let's just hop straight into it so we have enough time. Yo, Mod, what's good? Mod's in the building. So we're gonna design a Facebook newsfeed, but we're gonna go straight blank whiteboard. So first, we're gonna want to gather our functional requirements. What do we want? What do we want our system to do? So I'm gonna grab first we're gonna grab functional requirements. Talk about scale. Grab non-functional. Then after we grab that, we're gonna figure out our data model. Then we're gonna figure out our APIs. Then high-level design. And deep dive. Then we'll do a bunch of deep dives. That's our framework. We're gonna start off with our functional requirements, which is what do we want our system to do? What are the functions of our system? So let's think about this. What do we want our system to do? And since I'm gonna put on a timer to keep this under, we're gonna spend the first 25 minutes getting to high level design, and then probably the next 25 minutes after that doing deep dives. But yeah, we'll figure out our functional requirements. Let me just quickly check everything's working on my end. Check my burner. Cool. Looks like everything's good. We have a lot of ground to cover. So what are the functional requirements? We definitely want our system to view a news feed from friends they follow. Maybe view a newsfeed of posts from friends they follow. Maybe interact with posts. I'm not sure if that's we're gonna compare our functional requirements with theirs and try to follow the functional requirements they want us to cover. But let's say view a newsfeed, interact with posts. What else? Follow, unfollow friends. What else? We can unfollow friends. We can post content. Maybe update our profile. So what is that? So we can pretty much see our feed and see all the people we follow. Then we could actually interact with the post. Then we can pretty much view, follow and unfollow friends. We can post content if we want to, and then we could update our profile. Let's see how that checks out with what they are asking. Users should be able to create posts. Users should be able to. So this is their answers. Page to their feed. Users should be able to create. Okay, they essentially. So users should be able to create posts. Users should be able to friend and follow people. Yeah. Users should be able to view a feed of posts from people they follow. Yeah. Users should be able to page through. Yeah. So I think we just don't want them. We just don't care about interacting yet. We don't want to handle posting comments. And then yeah, let's update the profile here. Or we don't need to update the profile. So what's the scale? Usually for the scale, you're going to ask the interviewer. So you're gonna ask them what the scale is. They're gonna tell us something random like, where's the scale here? Oh, let's just see. For non-functional requirements, we're gonna say probably availability over consistency for our service. We just want the system to be up. We don't really care if people have different views of the newsfeed. We don't need the newsfeed to be strongly consistent. So prefer availability or consistency for the newsfeed. So we'll prefer availability over consistency for the newsfeed. Yeah. What else? We want low latency, probably sub 300 milliseconds for getting a newsfeed. So that should be really fast. Probably handle scale because Facebook newsfeed is gonna be handle scale. Because I mean, most of this system design you're gonna have to handle scale, but when you're interviewing for a company like Meta and they're asking you for when they're asking you to build a newsfeed specifically for Facebook, the scale is gonna be pretty large. So what else? We want availability of consistency. We want low latency. We want to handle scale. What else do we want to handle here? Is there any other interesting problems here? I think it's mostly just being able to do low latency newsfeed generations. I think that's the most interesting part of this question. Yo, thanks, man. Thanks for subscribing and watching. I got way more stuff to come too. Okay, let's see what they say. Functional requirements was the system should be highly available, prioritizing availability over consistency. Posting and viewing should be fast, so under 500 milliseconds. So it should handle a massive number of users, and the users should be able to follow an unlimited number of users. Users should be able to follow. Should be followed by. Okay, I didn't capture this. No, I'm just teaching system design concepts. Essentially, that's what I'm doing on my channel. I'm not interviewing, but a lot of people on my channel are interviewing. It's recruiting season, so I'm posting lots of videos for them. So let me know if you're interviewing anywhere and you want me to cover that specific company. So users should be able to follow an unlimited number of users. Users should be able to be followed by unlimited. Okay. Those are the non-functional requirements. What is Facebook scale? I mean, Facebook scale is like 3 billion users. Let's just say we have 3 billion users. I don't know. I don't think for system design, we're going to try to do that. So let's just say we have 1 billion users. Or let's just say we have 500 million users. So that's already crazy scale. So now we have the functional requirements and the non-functional requirements, and it kind of matches usually what we have here. Let's just dig into our bro. The dude couldn't pass his physical. That's why. So let's figure out our data model. What is our data model gonna look like? How are we doing for time? Our data model, let's just say we have simple users. We have simple users here, and we're not gonna fill this out right away, but we're gonna fill it out eventually. But we have friends, and then we have post. So users have the different users, and maybe friends say who's friends with who. Maybe we'll be using a graph database though. Then we have our specific post, and yeah, I think that's literally all we need. Raccoon was good. I think for data model, these are the main tables we need. Let's see if that checks out. Yeah, they have the same thing. So, yeah, starting with the core entities give us a set of terms to use through the rest of the interview. We pretty much have a user we can follow, and then we have a post made by a user in our system. Cool. Let's get into the API. Bro, you just screenshot like this, and then you click on it. It pops up real quick. You'll pop when you pop it. It's gonna pop up in the bottom corner, and just quickly click on it. We're gonna build our APIs. So we should be able to get newsfeed. We should be able to post friends. This is description. So description. Fetch the news feed. Fetch the newsfeed for a. Yo, maybe there's a bug in your thing. How old is your Mac? Fetch the newsfeed for a user. Return a bunch of posts. Dude, what the? Yo, Puberon, let's go. We're Yo, nice to have you back. Let's see. Dude, what the hell's up with my shit? Yo, we're designing a newsfeed system. So I think these are all the API endpoints we need when we get like returns. Did we do the? We're on the first one. We're gonna I just started the stream, but in this stream, what we're gonna do is we're gonna start with designing newsfeed, then we're gonna design Messenger, and after we're gonna design Facebook Live. So we're just gonna like knock off all three and hopefully learn a bunch of stuff. So, what do we have here? This is our APIs. Let's compare it to what they have. So they're saying, okay, we're able to post. We have that. Able to create post. We're able to. You want me to make a day in the life? Yeah, I'm down. Maybe I'll do a vlog with my friends or something. But we have posts. Yeah, we can create a friend. We can get the feed. How do we delete people? Okay, they just use the same post for deleting. Our last crime is to view our feed. Okay. Yeah, we kind of had the same endpoints. Okay, let's move on to the next part. We have our data model. We have our functional requirements. So let's get into Alex. I don't know. I'm gonna go with I'm gonna go with Chiefs just for history sake. So let's get into our high level design. What about you? So let's build a high level design that hits all of our functional requirements here. So we're pretty much, let's do the simple of being able to follow and unfollow friends and also post content. And then afterwards, we're going to figure out how to view the newsfeed because that I think is a bit more interesting. So let's start off with being able to follow and unfollow friends. So we're pretty much going to have our clients. We're gonna have a microservice architecture, so we'll have an API gateway. The clients will talk to API gateway. They're gonna pretty much be sent over to. We're gonna have our CRUD service, and eventually we're probably gonna have we'll probably have like a micro or a service for a friend service maybe for following and unfollowing friends. Maybe we'll have one specifically for posts. Post. So this is gonna handle uploading, and then maybe we'll have one for reading newsfeed. So we'll have a newsfeed service because I think the newsfeed service here. So for follow, we can use a bloom filter layer to curate the suggestions that are inconsistent or do not. I read a little about it last night, bro. I don't know anything about bloom filter, but I'm gonna look it up during this. What does a bloom filter do? Let me look into it real quick. But I think we're gonna have a microservice architecture where we handle everything related to friends here by itself. Newsfeed, we want the newsfeed system to scale independently because newsfeeds are gonna be very complicated, and it's gonna like generating the newsfeed. We want that to scale independently from everything else because that's pretty much the hard part of this question: is how do we generate low latency news feeds? Posting and the friend service is pretty much simple CRUD operations. So this is kind of what we have here. So we have our API gateway that routes us to our specific service. We'll have, so let's say for following and unfollowing friends, we'll probably have a database here. Let's just say it's like a graph database. Let's just say it's a simple database for now. Probably would be some graph database in order to efficiently query like who your friends are. Let's just say graph database, whatever. But we have our friend service, and they're gonna pretty much follow and unfollow friends. So pretty much when they want to follow a friend, they're gonna send a post request to our. Yo, Shashwat, what's good, man? Nice to see you. I'm gonna look into that bloom filters in a second too. How are we doing for time? Nice. So pretty much, when we do our newsfeed here, we're gonna have a what did they ask you, man? Yeah, it's good to just go through interview processes and learn how it goes, and it'll always be useful for you in the end of the day somehow, some way. Which questions? Okay, but view a newsfeed of posts from friends to follow, or to follow and unfollow friends. What they're going to do is send post requests to our API gateway. That's going to route them to our friend service. Our friend service is, depending on if they want to follow it, unfollow it, they're gonna send a query to our database. We're gonna use a graph database in order to quickly figure out who's friends with each other. Like yeah, it allows us to easily just visualize our data better and easily figure out and um, friends and people who are not friends as or unfollow friends as well, and also figure out like degrees of separations and stuff like that. So for our post, let's see, we could probably have a separate. Yeah, we'll do strong consistency with a graph database. You're right. I think we'll have we'll have a different database for our specific post. We don't want to store that in the graph database, and we'll probably use S3. We'll also have S3 as well. So our post service will store people's posts in S3. Let's see. And yeah, that's going to handle posting content as well. What DB for posts, it's going to grow real fast, right? I think. Yeah, we could probably just use DynamoDB for our post because we said that we want availability over consistency, and DynamoDB is highly available and scales horizontally really well. So we don't really need to worry about that out of the box. Yeah, we can probably use DynamoDB. Yeah, if we use, but in our post DB, we're not actually gonna store raw post. What we're gonna do is the post service is going to get is maybe we'll just stream binary data straight to the post service. But what it's gonna do is gonna upload it to S3, and we're gonna have an S3 URL here inside S3. Or yeah, we're gonna store all of our binary data in S3 and not in the post DB, and then we're just gonna store the URLs in post DB in our post DB. So yeah, we're never gonna store the binary data there. What else? We will have to then store post data. Yeah, we're gonna store post data separately in here. I think that's a pretty common pattern because you never want to really store your binary data inside of a database, especially if they have videos and stuff like that. Usually you just want links to blob storage. Like another thing we could do is also make them upload directly to S3 as well, but I think if they just upload it here. That's not like likes on like interactions and stuff. We're gonna store in our post DB as well, or we're gonna store it in DynamoDB, but we don't need to handle that here. We're not handle like we don't need to create a table for that because that's not part of the functional requirements. That's below the line here. Let's see. It's below the line. Yeah, Alex Zhu's book is good. I have this thing right beside me. Okay, let's just look through. Let's just make sure we're not getting ahead of ourselves. So how should users be able to create posts? Let's just make sure we're right here. So dealing with the first requirement, we only need to create posts and have them accessible by their ID. We're gonna start with a very basic thing here. Yeah, we pretty much have that here. We have our post service, so we're doing that. What else? We have our own post database too. I think what's the framework of practicing? Just do what I'm doing here. Practice the same way I'm practicing and just work through a question and just work down from top to bottom on this. It's all about practice. So yeah. So they're using DynamoDB too. So I think what we have there is good, but they're just gonna store it straight in the database. Users should be able to friend and follow. Functionally following or friending is establishing a relationship between two users. This is a many. Typically, okay, yeah, similar to what they're doing. Typically for a graph, we'll use a purpose-built graph database like Neo4j. However, okay, they want to model the graph themselves. We have simple requirements in this problem, so we'll keep it. Okay, they're just using a simple database. They're gonna have a follow table using an. No, this part's free. This part you have to pay. This other one you have to pay for it. This one's free. The following user to ensure we can look up. So they're gonna create a follow table with user following and user followed. This allows us to quickly check if a user is following another user. We use a partition key on the following user to ensure that we can look up all the users they're following. Yeah, okay. Like basically, they're just modeling the database without using a graph database. They're just using a regular database. But they're gonna have a following table. And how would we structure that following table? I think what we can do is if we're gonna use DynamoDB or something, what they said is they're gonna have. Do we say this is, what's the name of our table here? Like we're gonna have our friends and friend. We can be like user ID and friend ID. We could do following. Something like this, following user ID. So we can have the current user ID and the person we're following. This is the primary key. And this is also a primary key too, so it's a composite primary key. And details about the created at, updated at. So basically we can look for all friends of a user, and we can look for and we can quickly check if we're following that user or not pretty easily. Or like, yeah, we could just look, Ruben, what's good? We could easily follow yeah. Essentially, if I want to see all the friends for all of the friends of a user, I just query by the user ID here. If I want to query by all, or like check if someone's if I want to check if I'm following someone, then I just query by these ones. And yeah, we could have a unique constraint, so we can't have multiple rows where the user of this as well. And then pretty much for each relationship, we're gonna have two rows in this table. Like if A is following B, we're gonna have one where user ID is A here, and then the user ID is B here, and another row where it's a reverse. Why not following? And isn't the why not two tables, following and followers? I don't know. I feel like having two tables of that is just gonna make things more complicated than it needs to be. Like we have to query two different tables, and then since we have two different tables, the thing is, when we have, if we have two different, or well, Sabaj, like if it's in SQL, it's gonna look like this, but it's in SQL, it's gonna be like that. But they're using DynamoDB. That's kind of why they're building it in that specific way of user ID and following user ID all in. Like they're pretty much joining the two keys. Mo, what's good? So they're using DynamoDB, so it's a bit different. So they're creating so they're probably joining these joining these two keys, and then doing like that's probably all just gonna be yeah. We can use a partition key on the following. Yeah, it's like a key value store, but this is actually going to be the key that they're going to query by. Probably in the application layer, they're gonna combine those and then do the query. Because usually you're just doing like gets for a specific user ID. Like it's not actually gonna be two separate rows or two. It's not, yeah, because let's look at there's a DynamoDB section here. I only used it a little bit. So there's a partition key and a sort key. So I think what they're saying is this is gonna be the partition key. Following user to ensure. Yeah, I don't know exactly how they're gonna define that. Honestly, I haven't used DynamoDB too much, but yeah, that's pretty much how it's gonna work. Users should be able to view a feed of posts from people they follow. Okay, how are we gonna do that? Well, we're gonna have our newsfeed service. What we're gonna do is, like I said before, we're going to want to pre-generate our newsfeed. And pretty much what we're gonna, okay, let's just think about the very basic flow first. So essentially, the client is gonna perform a GET request for their news feed, right? Let's see, client makes GET for news feed. After client makes a GET for the news feed, we're gonna figure out who client follows. This is the very naive approach right now, but we're gonna figure out who client follows by querying our following table. Then we're gonna query following table to find out who the client follows. Google guy, what's up? Then we'll query our post DB to find out posts. So since we know who we're following, query the post DBs. Query the post DBs using using results from step 2, because now we know who their friends are. And after we do that, after we query posts using results from step 2, we're gonna send that back to the client. We're gonna need some like cursor-based pagination or something for sure. We're gonna need pagination because we only want to send the last. We want to probably send like 10 or 20 at a time, and then have sort of an infinite scroll where we just keep loading more and more. But this is the very naive approach of pretty much generating the news feed as when they query. I think Puberon, like that makes sense, but we want to stick to our core functional requirements. Like it's a short interview, and if we try to do things like trending posts and stuff, I think that's not part of the functional requirements, right? So that's a very naive way of being able to grab a news feed So let's just think about that. So we get all users who are given users following. We get all posts from those users. We sort the posts by time and return them to the user. Yeah. There's a lot of complexity here, but let's ignore it for now and create a naive base from which we can. So yeah, we're going to do a naive approach here. In a real interview, I'd explain this exactly like that. I know there's not going to scale, but I'm going to start with a naive solution and then solve the scaling problem separately. A very common failure mode for candidates we work with is that they get lost in the weeds of a particular scaling problem before having, okay. So yeah, I guess it's similar to how we do coding interviews where we kind of just do that naive design, and this is a naive generate sort based on note use cursor based pagination to page results, generate news feed, on pull. So this kind of naive approach, but yeah, they did the same thing. So before we're done, we'll have to. So how do we want to index our data here? Pretend we're using a SQL database. What we're gonna want to index on, I mean, we already have an index on user ID, but we're also gonna want to index on following user ID as well. Well, since it's part of the primary key, we'll also have a unique that'll be indexed anyways. But yeah, we want to index by the things that we'll be querying. So we pretty much when you're figuring out indexes or you're trying to figure out primary keys when it comes to DynamoDB, you need to figure out access patterns. And our access patterns is pretty much by we need to figure out who a client follows. So we pretty much, if we have a index on the user ID, we can easily find out who they follow. We can query post from the DB. So pretend we have our post DB. Let's say we have a post ID here. That's the main primary key. And then let's say we have our post ID. We also have our user ID here. And then we have our timestamp. Yeah, well created at is there already. So what we do is we probably want to index the user ID because we want to be able to quickly find, once we figure out a list of users they follow, we want to figure out all the posts for those users. So we want to create an index definitely on the user ID here. And these are already indexed because they're primary keys. This is already indexed if we need to look for a specific post. But yeah, that's pretty much how it's gonna work. And yeah, we could probably have a secondary. We can have a secondary index, so we can have it on user ID and created at. So we can create a composite index on first by user ID, then created at. Okay, yeah, we can solve this by adding a partition key on the post table with a user ID and a sort key. Yeah, they're using DynamoDB, so I need to refresh a little bit on DynamoDB. Here we have a naive service. For a given user, we first request all users they follow from the follow table. Then request all the posts from those end users from the post table. Then we sort all of those by timestamp and return results to the user. Our user may be following lots of users. Each of those users may have a lot of posts. The total set of posts may be large. Yeah. that's kind of our, yeah, this is kind of our design right now, but I don't think we're gonna go that much further with this naive approach. So there's no point in like trying to just like make it work, because there's things that aren't gonna scale, because we're doing massive queries on friends, we're doing massive queries on post, and then we have to sort that and then just paginate that. That's gonna be a very, like, the newsfeed endpoint is gonna have crazy latency. Users should be able to page through their feed using infinite scroll. Like I mentioned, we're gonna have cursor based pagination. So pretty much the client is going to maintain a timestamp. So client will maintain a timestamp. Client will maintain a timestamp. It's gonna pretty much send that timestamp to the backend. That way, when we filter, we can figure out. We can pretty much figure out. We can only start the time. We can filter by where the timestamp is greater than a specific timestamp we already have. Essentially, that's pretty much what we'll do there. We want to be able to support an infinite scroll like experience for your users. To do this, we need to know what they've seen in their newsfeed already. Fortunately, what they've already seen in their feed can be described fairly concisely. They have a timestamp of the oldest post that they looked at. Yeah, that's similar to what we said there. Since users are viewing posts from youngest to oldest, the oldest timestamp tells us they've stopped and provides a great cursor to grab the next set of posts. Since we can tolerate up to a minute of eventual consistency, we want to accomplish this by keeping a cache of recent posts for a user in the distributed cache. So they're caching already. So when the user requests their feed for the first time, or if we don't have a cache entry, we'll build it using the post and follow tables. Okay, yeah. Yo, Pierre, what's good? Okay, this makes a lot of sense. Definitely when we're performing these queries, like who a client follows, we can build a cache, like a Redis cache. And that's gonna store who they follow, and also maybe loads in like a 500 different posts. And yeah, when a user requests the next page, they'll send us the timestamp of the oldest post they've seen. Cool. So this is the very naive approach of how to generate a newsfeed. I think it's good to talk about, but definitely we want to improve on that design a lot. I think the main thing here is there's just super low latency, or super high latency when it comes to generating the newsfeed, because we're generating it on the go. How do we handle users who are following a large number of users? Okay, what do y'all think about this? This is our high-level design. Let's get straight into our deep dives. Pierre, thanks for watching, man. How do we handle users who are... We also need to handle celebrities in the non-functional. How do we handle users who are following a large number of users? I think we can cache that for sure. Yeah. Hot load the list of following users, having a queue take care of it. What do you mean by that? We definitely want to cache that in Redis. we want to definitely cache that in Redis. So we probably want to cache who a user is following and who's not following. Okay, so what you're saying is when someone okay, what you're saying is in our Redis cache, we kind of preload all of the people they're following, and when they unfollow and unfollow, we have an asynchronous job updating this queue, updating this cache. That makes sense. Yeah, but then there's a bit of latency then when it comes to do that. But what we'll say is, how do we handle users who are following a large number of users? I mean, we'll cache use Redis to cache we'll use Redis to cache all of the followers for these users. As this user unfollows people, we update both the DB and cache, kind of like write through cache. But yeah, that way we just have to load in from memory. We don't have to do massive queries on the database. That way we can avoid massive queries on our DB and use Redis for fast in-memory operations. Okay, they're doing... Oh, yo, Alpha, what's good? I mean, every day we grinding, man. Bro, let me just actually... I think if we keep following these... Let's just get straight to... the design that we know is going to work, which is more of a fan-out service instead of querying on loads. Because we know that we always knew we were going to get there, but I was just kind of following the steps here. But how do we handle users with a large number of followers? How do we handle uneven? So let's see. If a user is following a large number of users, so let's see the rationale here. So if a user is following a large number of users, the queries to the follow table will take a while to return, and we'll be making a large number of queries to the post to build their feed. This is known as fan out. A single request fans out to create many more requests, especially when latency is concerned. Fan out can be a problem, so it makes for a good discussion point for system design issues. What can we do instead? Your instinct here should be to think about ways that we can compute the results on write or post creation rather than at the time we want to read their feed. Okay, that makes a lot of sense. I think earlier we said this is naive approach and we want to optimize it. So I think that's what we're going to do here. So how I'm thinking of doing this is pretty much what we're going to do is we're going to have our Redis cache for a post. And pretty much as in our Redis cache, we're going to have... Thanks, bro. Appreciate it. In our Redis cache, we're gonna have key value pairs of pretty much user ID, and this is our and then these are posts, a list of posts. So what this user ID 1 and it has a bunch of posts, user ID 2 and it has a bunch of posts. But what this is essentially gonna act like is gonna be cache the user's newsfeed. So we're trying to cache the user's newsfeed here. So essentially, when they get the newsfeed, they can just pull from this pre-built cache, and we don't have to generate it on the fly. So how is this gonna work? Pretty much, when a client actually posts a request, this is we're gonna generate the newsfeed on write instead of read. So I think that's what we're doing here. Generate newsfeed on write instead of reads. So pretty much, when a client goes to write to the database, it's gonna do all the things like figure out this person following, right? And then it's gonna also figure out, after it gets a list of all the people this person's following, it's gonna figure out all the posts there, all of the new posts. Or actually no, like, because they're writing a post, all we need to do is figure out who this person is following, and then pretty much, yeah, post into our database. But then all we need to do is actually write into each of the people. We can look up who my followers are. We can do the reverse of figure out, instead, since we're on write, we need to look for look for who's following me. First, actually upload or insert the post to DB, right? Secondly, look for who's following me, and then pretty much write into their cache. That's kind of the steps there. So we write into their cache. Now, when clients go to read, they just pretty much look into their cache, and their cache should be ordered pretty much by the cache should be ordered pretty much. We can do like a queue. So yeah, what we can do is have a priority queue or something, so that they can pull like the 10 latest every single time they go to grab from the cache, like use a priority queue for each of the users. So yeah, look for who's following me, right into their cache. So that's how we generate it on write. How they did it is using a feed table. One naive, it's a shard follows and posts by user ID. How does this even, why would you even do this one? By user ID and scale horizontally. If we have 4 shards where each shard contains I don't even know. For users who follow a large number of users, we can keep pre-computed feed table instead of querying the follow and post table. We'll pull from this pre-computed table. Then when a new post is created, we'll simply add to the relevant feeds. So they're kind of having a feed table per person. That makes a lot more sense than what I'm doing here, actually, because we don't just want to write in someone's Redis cache. We also want to persist that as well. Like writing into the Redis cache makes sense, but we probably also want to persist that. So let's just add that here. I don't know if this is gonna be. It's probably gonna all be in the same database, but we're gonna have our own feed table. And yeah, the follow service. We need to write to millions of feed efficiently. So let's dive in. Yeah, that's true. Maybe for maybe for celebrities, we read celebrities. Read celebrities. Like grab posts of celebrities. Like this is just a thought right here. Grab posts from celebrities on read. Grab posts from regulars, people, or generate on right. I think this is a hybrid approach. So what are we gonna do here? Yeah, we're definitely gonna want to add a queuing system as well. So pretty much what we're gonna do, we're gonna have our newsfeed service. What we're gonna do is when people post, we're going to like as posts are coming in, we're gonna want to handle that asynchronously. So we can create a job for that. I'm just trying to figure out where we want to do the job for that. This thing's already post. So let's see what we want to do. So when someone posts to S3, how do we handle? We need to write to millions of feed records. Okay, how are we gonna do that? Yeah, pretty much when they do a post, we don't want to do that all in one go right here. Essentially, what we're gonna do is when they're gonna insert into the database, we're also gonna have a queue where we're gonna basically when they post, we're gonna have this queue for doing the fan out. So pretty much when they post, they're gonna also post to this post queue, and then we're gonna have different workers consuming the post queues and doing the fan out. Maybe something like that will work. What do y'all think? Fan out workers. We have the different fan out workers who's gonna pretty much consume from the queue and then insert in the newsfeed and probably update the Redis cache as well. So that's what it's gonna do, and it's also gonna figure out like the friends and stuff. So it's gonna figure out how to fan out, but we're gonna try to do that asynchronously from actually uploading the post. So what is the most naive approach? We shotgun it, do it all in one go. One sec, quickly check in. Nice. Try to do it all in one go. One post. Yeah, async workers. Okay, a better option would to have a. Yeah, that's kind of what I did. Yeah, that's kind of what I did. Some delay. Any queue will work here as it supports at least once delivery. When a post is created, we create an entry in the SQS queue with the post ID and the creator. Each worker will look up the followers for that creator and prepend that post in front of their feed entry. We would also get even more. Some workers are doing a whole lot of work. Instead, just writing, we could also partition. We could also include a partition. Okay, that makes sense. What are hybrid feeds? Okay, that's similar to what we said before. But we can choose which accounts we'd like to pre-calculate into feeds and which we do not. For Justin Bieber and other high following accounts, instead of writing to 90 million followers, instead we can have a flag on the follow table which indicates that this particular follow isn't pre-computed, and we'll ignore requests for this user. On the read side, when the user requests their feed, we can grab like the celebrities. That's kind of what I mentioned here. That's actually, yeah, I like that approach too. This hybrid approach allows us to choose whether we fan out on read or write. And for most users, we'll do a little bit of both. This is a great system design principle. In most situations, we don't need a one-size-fits-all solution. Doing the merging feeds at read time versus write time means more computation done in the feed service. Yeah. Okay, how can we handle uneven reads of posts? What does this even mean? Request to get their feed. For the vast majority of posts, they will be read for a very few days and never read again. For some posts, especially those from accounts with lots of followers, the number of reads from to this point, our feed service has been reading directly from the post table whenever a user requests to get their feed. For the vast majority of posts, we will read a few days and never again. For some posts, especially those from accounts with lots of followers, the number of reads the post experiences in the first few hours will be massive. And post 2. Okay, I mean, let's just, for handling this case, why don't we just cache? Why don't we just build a cache or cache? I mean, we'll do, how do we handle uneven reads of posts? We'll cache posts, and we'll use cache posts, and we'll just do count the frequencies of reads and evict, and we'll evict posts that aren't read too much. Like that's our eviction policy, based on frequency of reads. Okay, post cache with large. A good solution to distribute cache between the readers of the post table and since posts are barely edited, we can keep a time to live on posts and have our cache evict posts that are least recently used, as long as our cache is big enough to house most recent posts. Okay. Yeah, they're gonna hit our post cache. Just spamming Redis. Okay. So the difference is redundant post cache. What does this mean? You have to house the. They just add a bunch of caches, so they're just like horizontally scale the caches essentially. Okay. Cool. Nice, we got through it. What is expected from a senior candidate? That was actually pretty complicated, but I think fan out. Let's talk to GPT what it means by fanning out on read and fanning out on write. Nice. Okay. Cool. We spent an hour on that. We spent an hour generating a news feed. There's lots of really good stuff there. I do full stack. Yeah. Essentially, we have a really good grasp of that newsfeed question. That was a really good question. Let's move into designing the messenger. Probably need to take a quick break. Where is it? Okay, now we're gonna design WhatsApp or Messenger. Cool. This is that was fun. I'm gonna label this. Fan, what's up? What about you? What do you do? Do Nice, man. Are you gonna try to switch into engineering at some point? So we designed a news feed, and now we're gonna design Messenger. That was a lot. I'm gonna put a timer. I'll be right back. Gotta take a quick break, and we're gonna get into designing a news feed. Let's get it. Woo. Next stop, designing a messenger system. So how are we gonna design a messenger system? Same thing. We're gonna go through our functional requirements. This is a crazy grind, but we're 33% of the way. Maybe, yeah, let's get it. 33% of the way. Functional requirements. Then we're gonna talk about some scale, non-func requirements. What else? How's it in India? I don't know. I'll probably in this year I'll probably do it for at least half of my weekends, bro. I'll spend the other weekends actually doing fun stuff and going out and stuff. But honestly, I like to. I'd rather during the weekends. I'd rather do this than some of the other stuff. But like if I'm gonna do stuff, I'd rather just travel. You know what I mean? But I travel quite a lot. I travel probably a few months out of each year, so I try to save all my energy for doing fun stuff when I'm traveling. But yeah, it's a lot, man. Trust me. Okay, what we do, functional requirements, scale, non-functional requirements. We're going to talk about our data model. We're going to talk about our APIs. Then we're going to get into the high-level design. Then we're going to deep dives. What's kind of cool about, what should we think about, maybe for the deep dives, we'll think about that later, but let's get into our functional requirements. So for our functional requirements for Messenger, let's try to go through this fast. We're going to have pretty much users can send messages to group chats. We'll just say 1 to 100. So if you're pretty much only talking to one other person, it's kind of like a direct message. So, but we can handle 1 to 100. Users can send messages to group chats. What else? I'm pretty sure that's all Messenger does. View a list of messages ordered by timestamp. So I open up my Messenger. I can view to a group chat. So kind of we can view a list of all my group chats. Then when we click into a group chat and we could see the messages ordered by timestamp. And then once we're in there, we should be able to send messages to group chats. Yeah, I think maybe we could just say text messages for now. Let's see. So users will be able to start. Users will be able to send and receive. Purbaran, like I said like a group chat of 1 to 100, and basically I think in our system we can treat messages as just group chats. So if it's just if it's a 1 to 1, if you are only one other person in the group chat, it's pretty much a direct message. But we shouldn't make a different, like we should just follow the same pattern. Like whether it's one person or 100, we don't really need to care. That makes sense. You should be able to send, receive. You should be able to receive messages sent while they're not online. Yeah, that makes sense. So we need to break this further. Okay, they want to handle media. Okay, below the line. So what are the non-functional... What are we thinking are the non-functional requirements? I mean... Low, late... Real time... Receive messages. Yeah, you're right. Receive messages in real time. You receive... Purbaran, what do you usually do on the weekends? Do you like to do the system design stuff? Or do you like to go out, or is it too hot? Nice. How do you play soccer when it's hot? Is it indoors? I see. So you receive messages in real time. Receive messages from chats in real time when you're online. Real time. So you should get it within 200 milliseconds when you're online. What else? We should receive messages from chats in real time. What are some other functional requirements? We should, or non-functional requirements. So I think in terms of latency, we need to be able to handle that. In terms of consistency over availability, we'd probably just rather have availability. Prefer availability. I mean, I don't know if that's that important for this one, but let's see. Van, you're right. You're right. Encryption of messages. That might be below the line, but yeah. Let's see what the non-functional requirements here. Guarantee delivery of messages. Oh, I see. I see. Guarantee delivery of messages. What else? High throughput, like lots of people sending messages. Messages should not be stored on centralized servers longer than necessary. The system should be resilient against failures or individual components. So, okay, since it's WhatsApp, okay, they said less than 500. Guaranteed delivery of messages should not be on central server longer than it needs to be. It depends if like WhatsApp or Messenger, I think, because WhatsApp, it will delete them, but on Messenger, I think it's stored in a centralized server. But yeah, should not guarantee deliveries, high throughput when lots of people sending messages to handle the scale. And what they also said is like fault tolerance. We don't want to lose messages. What did it say? Fault tolerance. I mean, that's kind of what we need in every system, so I'm not going to really write that down. So let's talk about our data model now. What do you mean? What do you mean concurrent load? Data model. What are we gonna have? We're gonna have users. Gigabytes of text. Are you talking about for the throughput or what? What do you mean by concurrent load? We're gonna have users. I think simple messages. Yeah, we have maybe. Okay. I think what the server is doing is it's just forwarding messages though. Like when we send text, text is always going to be much slower or much less. Like how much text can someone write? There will probably be a limit to maybe 500 characters, or even if it's like 1,000. We could easily just send that through the wire, and it'll pretty much like we'll just need to deliver it to that specific user. Billions of active users per second. Yeah, we're gonna have chat servers and we're gonna horizontally scale that. So we're probably getting ahead of ourselves a little bit here. But what we're gonna do is we're gonna have our chat servers and we can horizontally scale them so each Where's my glorious King Paul? I have no idea. I haven't seen him in a couple days or a couple weeks, but he's gonna hop in soon. So maybe we have our different users, and then for our users, we have different groups. We say this allows us to figure out who's in a specific group chat, and then the messages maybe are for. I'm trying to figure out how we want to model this. Do we want to store users, groups? And what are we going to store in messages? Just the raw message? I'll probably need to fill the messages out a little to kind of get it through my mind. So we're at message ID. Then what can we do to know who? I guess we can do group ID. Yeah, we'll have a group. Content. So what we can do is, yeah, sender ID. So what we can do here is when we have messages, we know who the sender is and we know it's to a specific group, and pretty much in the different groups we're gonna know who's in that group essentially. So if they're in a specific group, they can pretty much grab messages by group ID as well. Something like that, yeah. So I think we'll need a data model for that. Let's see. So users, groups, and messages. Let's see what they did. Okay, they have users, chats, and messages. Okay, they also have clients, which I didn't have, because yeah, a user might have multiple devices. So cool. Let's get into Okay, so we can walk through the functional requirements. Yeah, we have our users, we have our chats, then we have our messages and clients. Okay, cool. Let's look at our API interface and then first start building APIs to hit all of these different functional requirements. So we'll have post, chats. Maybe is this what's LLD? Chat ID. Maybe create a message. Sends a message to a. No, this is we're designing WhatsApp, so this is more product facing, but we'll definitely go a little bit deeper, but it's more product focused. System design question. So we send a message to we'll have a high level design also, but then we'll also deep dive into various components. So we're more simulating like a system design interview. I don't know if that's what you're asking. Which of the system design are infra focused? The ones that are more infra focused are things like the ones that are more infra focused are pretty much like design. Dropbox is a bit infra focused because you work with chunking and stuff. Add click aggregator is more infra focused. Let's see. I would say the ones that are more infra focused are like design a key value store. Let me look at this book. There's some infra focused ones for sure. Okay, yeah, design a rate limiter, design consistent hashing, design a key value store. Those ones are more yeah, top K. Those ones are more infra focused. But these ones that I'm doing are more product focused because I'm more of a product engineer. Yeah, web crawler is infra as well too. Because you don't really need to think about API, or you don't really need to think about the front end experience at all, or the product experience. You just need to literally, on the back end, it's just crawling all the different websites. This website is called Hello Interview. I might need a sponsor at some point. So let's see. Users can send, like I'm giving them free promo like crazy, but they're already popping off. So users can send messages to group chats. Yeah. Click into a group chat and see messages ordered by timestamp. I think what we need to do is, like if I was AFK, I need to be able to get my messages. Able to get messages. Maybe I can have like a timestamp. Maybe in the body, send a timestamp of my latest message for cursor, so the cursor works correctly. So we'll get messages. I'm able to get messages. Send the timestamp of my latest message to just fetch the new ones. Probably get chats. This will return just a message, just so we can act. This will return a list of messages. This will return a list of chats. What else? Yeah. So that will be able to get my messages. Yeah, that should be all the endpoints we need. Pretty much sending messages, and then we'll be able to get messages. This could be naive polling at first, but eventually we're gonna want to do a more of a push model and push it to the clients on writes. Then we can be able to get our group chats. So let's see how we do here. So we're gonna do high frequency being sent and received. For this interview, we'll just use WebSockets, do a simple TLS connection. The idea will be the users, we open the app and connect to a server. Yeah. So we're gonna do everything through WebSocket. So they're pretty much gonna be able to create chats, send message. Oh, I didn't have that. Get chats. Chats. Description. Create. So yeah, they're gonna be able to create chats. They're able to send messages. Then they're able to do attachments. We need a way to add, remove users from the chat. So each of these commands will have parallel commands that is sent to other clients. When the command has been received by other clients, they'll send an ACK to let the server know they'll be received. The message receipt acknowledgement is a bit not obvious, but crucial to make sure we don't lose messages by forcing clients to act. Yeah. When our chat is created. Okay. We're gonna get pushed events. We're gonna have WebSockets. So we're gonna talk about this in our high level design. So let's just move into our high level design as well. I did API endpoints here, but I think definitely to note we'll probably be using WebSockets for fast bi-directional comms. We have WebSockets for fast bi-directional communication. What else do we want? WebSockets for fast bi-directional communication. Yeah, that's pretty much what we're gonna do. I know we used APIs here, but we could easily convert these APIs into like the WebSocket protocol. Yeah, let's get into our high level design. High level design. So how I'm thinking about it right now is, of course, we're gonna have our clients. Our client is going to talk to some API gateway like we always have. Pretty much as it talks to the API gateway, it's gonna get routed to different things. So we're gonna have our maybe we just literally have a load balancer, but API gateway literally does that as well. I think like API, it's kind of a our API gateway could act as a load balancer too, but you can handle first the authentication, all that stuff. But here we're gonna have our messaging services. And what we're going to have is our database where we're going to be storing all of the different messages. So what's the first step? Users should be able to start group chats with multiple participants. So how is it going to do that? Essentially, yeah, the client's going to send a post request to the different... Usually when they start a group chat, they start with a simple message first. But in this database, we're going to also have... Like I said, we'll have our chats in here, and then we'll also have our messages. So let's try to visualize this a little bit better when we have multiple clients. So they'll pretty much just use the API gateway to get to a service. But I think once they're in our messaging service, they're going to create a WebSocket connection directly to the messaging service here. There's going to be bi-directional communication. There's going to be bi-directional communication. And yeah, there's going to be bi-directional communication for the client here. And let's see. So when users start a group chat, usually they'll send a message, and pretend the very naive approach is all of them is we have one server. So the naive approach, one server handling all WebSocket connections. Right? This is a very naive approach when we pretty much have one server handling all the WebSocket connections. Because essentially when they want to create a chat, the WebSocket just looks... It'll probably have a map to user ID and connection, WebSocket connection of one. So user ID has a so it could be and we'll talk about how do we horizontally scale that later. But pretend we have one server handling all of the connections. So when a user wants to start a group chat with multiple participants, sorry, what rang? Oh, it's this. That scared me for a sec. So essentially, what do we have? Okay, users, when they want to start a group chat, what they're gonna do is they're going to pretty much send it to the message service. The message service is going to see who's online, and basically it's going to store in the chats database pretty much that group chat that was going to be created, but it's also going to inform it's also going to inform all the clients that are also connected that this person wants to send a group chat, and we'll probably send over the message as well. And for the people who are not there, we're going to store it in the messages, but we're going to keep track that that message wasn't sent to them yet. We're basically going to tell them that that message wasn't sent yet. Basically, those other clients won't act, so we're going to know that we need to deliver those messages to them when they go online. But that's kind of how we need to start our messages. Chat metadata. Then we have a chat ID. So a user connects to service and sends a create chat message. The service inside a transaction creates a chat record in the database and creates a chat participant record for each user in the chat. The service returns the chat ID to the user. On the chat table, we'll usually want to look up the details of the chat IDs having a primary key. On the chat ID, we'll usually want to look up the details by the chat ID having a... Okay. Yeah, that makes sense. That makes sense. We can do this with a composite primary key on chat ID and participant ID fields. A range lookup on the chat ID will give us all participants for a given chat. We'll need a secondary global index with a participant ID as the partition key. I need to read up on DynamoDB a little. I'll probably do that probably right after this. But we'll need a global secondary index with a participant ID as the partition key and chat ID as the sort key. This will allow us to efficiently query all the chats for a given user. That makes sense. So they're using DynamoDB. So users should be able to send and receive messages. So yeah, like I mentioned here, that's what they're going to be sent when they send messages. We're going to write into the database that message, and pretty much when they send the message, they're going to send it for a specific chat ID. Yeah, because they're going to do create a chat here. Or when they post a message, they're going to post it for a specific chat ID. We're going to query the chat ID to figure out who we need to send this message to. And we're also going to at the same time, let's see, let's query the chat database to figure out who we need to send it to. Then once we have a list of people to send it to, we'll since we're in this since we're have all the WebSockets in this server, what we're gonna do is look for all the clients and then send over those messages to all the different clients so they get it in real time. And the ones who act, we won't store their messages in the database, but for the ones who don't act, we'll store it in the messages so that they can retrieve it later. So yeah, they have a single host for the chat server. This is obviously a terrible solution for scale. And you might say to your interviewer to keep them from itching, but it's good as a starting point, and we'll incrementally solve these problems. So for infrastructure style interviews, I highly recommend reasoning about a solution on a single host first. Yeah, that's what we're gonna do. On how to, so we don't want to scale first without thinking about the mechanics. So when a user makes a WebSocket connection to a server, we'll want to keep track of their connection with a simple hash map that will map a user ID to a WebSocket connection. That's kind of what we're doing here. This way we know which users are connected. To send them a message, a user sends a message to a chat server. The chat server looks up all participants. The chat server looks up the WebSocket connection for each participant and sends them that. Yeah, we're making really strong assumptions here. We're assuming all users are online and that we have a WebSocket to them in that server. That makes sense, and we're going to think about how we scale that. Users should be able to see messages sent while they're not online. So I think we already talked about that briefly, but what's going to happen there is pretty much, let's think about it. And after this, guys, I'm going to go watch some episodes of Severance. But anyways, what was I talking about? Let's do the next part of this. Users should be able to. So I think this is where the ACK comes along. When they send a message, they'll ACK or not. And depending if they ACK or not, we're going to store in the messages DB if they didn't ACK, so that when the client connects, we can just look in the messages ID to find all the, it's kind of like a mailbox for them. Let's keep an inbox for each user, which will contain undelivered messages. When messages are sent, we'll write them to the inbox of each recipient. If they're already online, we can go ahead and deliver the message immediately. If they're not online, we'll store the message and wait for them to come back. So to send a message, user sends a message to the chat server. Yeah, this is what we said we're gonna do. Is there transactions in DynamoDB? Wow, I didn't even know that. Wow. That's crazy. Yo, Puberon, do you use DynamoDB at work? Strong and consistent reads. Bro, nice job, man. Yeah, I'm gonna read about DynamoDB, and I need to read about Bloom filters. What the hell is Bloom filters? Where did you read about Bloom filters? Okay. The chat looks up a WebSocket for each of the new participants and attempts to deliver them the message. Upon receipt, the client will send the ACK to the chat server, will then delete the message. Okay, pretty much first when the client sends a request, we're gonna insert into our database. Puberon, how come you're studying system design? Are you interviewing? Most of the people who follow me are actually interviewing, or they're just trying to learn for fun. I see, I see. How are you doing with lead code? Are you good at lead code? And what are you trying to switch to? How are you with lead code, bro? Nice. Bro, you got this, man. You're smart. Look up the inbox and find the under for each look up the messages, write those messages. Okay. Okay, cool. This is cool. You should be able to send, receive media in their messages. How are you with lead code? I mean, let's store attachments in S3. Or do we want to deliver attachments right away? So what we can do is we could actually just send the binary data straight to them. Um, yeah, we can store stuff in S3 and have like TTLs on the objects there. Yeah, I'll do some leak code questions right after this. Yeah, Alpha Code, literally only fan companies like to ask leak code questions. But Alpha Code is cracked at leak code. I'm gonna fill up my water bottle. Give me a second. Ben, are you in the industry or are you in school? So users should be able to send and receive messages. Yeah, practical stuff. I actually like it when they do practical stuff instead. I think, yeah, users will be able to. We're going to store attachments in S3, and in the database, we're going to store links to the S3. And pretty much when clients receive messages, they'll download it from S3, and we'll have a time to live on S3 or something like that. Or just not even a time to live. We'll have S3, and when they lose the URL, they lose the URL. Yeah, we have so we're gonna send attachments separately. Yeah, we can have CDN based caching as well. Depends on like how many people are gonna be using that though. Like that might be over engineering, because if I'm in a small group chat, like how often are people gonna be grabbing that message, right? After you send a message, you might not see that image for a while. I've used DynamoDB for side projects. One image, but Puberon, like we over here, we said that group chats are only gonna have 100 participants. So I think we can treat those as separate messages across separate group chats. So user sending is annoying, it's bandwidth and storage intensive. While we could potentially do this with our chat server, it's better to propose built-in technologies for this. This is in fact how so WhatsApp handles attachments using a different server. Like ours, we're going to be using S3, and clients will actually upload and download directly from S3. Let's see, we can do that. So this is the worst approach, where we just keep attachments straight in the DB. This is not a good solution because DynamoDB is not good for large binary blobs. That makes sense. Send attachments via a server. We can have have a chat server accept the media and then push the blob storage. Yo, Michael, what's up? Wow. What do you do for top K in memory? Do you just use Redis? Do a Redis priority queue or something, or Redis heap? But can you just build a service that kind of acts like Redis? Like you want to do things in memory? Or do you need to keep querying the DB? Yeah. Because querying the DB is kind of bad. I see. Damn, yeah. That's kind of hard. When you look at this like top K one here, they just said use Redis. I mean, these guys kind of just spam using Redis. Okay, talk directly to blob storage. Yeah. Okay, awesome. 1 second. Let me put on some headphones. There's some noisy stuff going on outside. Test. Okay. Let me test one. Shoot. Yeah, so ideal. Yeah. Okay, y'all, Puberon, you use Redis a lot at work. That's interesting. Yeah, with a lot of these questions, they actually use Redis for, yeah, specifically for that, for like building out global locks, like for Ticketmaster. Okay, how do we handle billions of simultaneous users? So, let's get into this deep dive, and this is gonna be interesting because our approach is very naive right now. So I think, how do we handle billions of simultaneous users? So I mean, obviously, what we're gonna have to do here is horizontally scale, or I mean, we could vertically scale too, but that will have like limitations. So client here. What we can do is horizontally scale our message service, right? We can have a bunch of message services, and what we can horizontally scale these. So now the different clients are going to be talking to different messages, or are going to talk to different messaging service. That reduces the load on one single message service. But now we have a problem. Let's say we can scale horizontally, but our new problem is we can't easily we break our broadcasting. Pretty much because we break our broadcasting because we before, when all the WebSockets were on just one server, we could just easily broadcast it. But what if somebody in the group chat is on a different server? What if someone we want to send a message to is attached to a different server? So if someone we want to send a message to is attached to a different server, we're going to need to relay that message to their server, and then once that server gets the message, it could relay it to that client. So to do that, pretty much what we need to do is relay messages to the client, relay messages to the correct server, to the servers of all other chat members. And so we can relay messages to servers of all other chat members. Yeah, and then so what we can do there is we could do like a pub sub model where, or what do y'all think? What do y'all think in the chat first before I get into my solution? I kind of already know what to do here, so I want to get y'all like figure out what everyone here is thinking. I need to brush up on my data modeling. Brush up on data modeling. Maybe I'll do videos just specifically just doing data modeling. in both SQL and DynamoDB. I think that'd be interesting videos where it just focus, because data modeling is very important for, yeah, we want to have message queues. Message, like, what are the topics or the message queues? Yeah, we'll probably have message queues by user ID. So we'll push messages for user IDs, and whoever subscribed for that specific user, or whoever, pretend this is user 2, right? If this is user 2 and it's connected to this messaging service, it's going to subscribe to this queue. So pretty much what the client will do is it's going to, when a message is sent, it's going to push for all the users it needs to notify. It's going to push it into this queue, and all of the whoever subscribed to it, the person subscribed to that queue, or whoever has a WebSocket connection to that user, and all users. Yeah, we could have it by group ID. Or by user ID. Maybe group ID makes more sense. Or maybe user ID makes more sense here. I don't know. Let me think about that. But whatever we do, essentially what the flow is we're going to know who subscribed. Or if I have a WebSocket to a specific user, I'm going to subscribe to their queue. So then I'll be notified when I need to send them a message, and then I'll just pull from that queue and then send it to that user. Yeah, then you would just have to join 2 tables to find who subscribed to which users. I don't know. Okay. I think both will work, but that's kind of how we'll scale that. What do they do? What's the optimal? So you can create a subscription for a given user ID. So I think they're breaking it up theirs by user ID, and then publish messages to that subscription, which are received at most once by the subscriber. On connection, when a user connects to a chat server, they'll connect to the pub sub to subscribe to the topic for that user ID. Any messages received on the subscription are forwarded on to the WebSocket connection for that user. When a message needs to be sent, we publish the message to the pub sub topic for the relevant user, and the message received by all subscribing chat. Those chat servers then forward the messages to the users. Yeah. If there's no, but it's okay because we already, okay, yeah. So I think they're subscribed to topics, but they're doing it by user ID. What are some worst approach? Paul, what's good? Bro, you missed out on like 2 hours of system designing. Were you out? Or were you in the Coding Jesus live streams? Another approach for us. Which system are you talking about? Pause. See, another approach for us to use is to always assign users to a specific chat server. What games are you playing? Oh, you just hop on YouTube after that, huh? Oh, sick. Oh, so another way is we can use consistent hashing of servers and then just directly do server to server messaging. That's interesting. That sounds complicated. You got this, bro. Keep a Kafka topic. Every user. Okay, so they're gonna use like a Redis pub sub. What are they gonna use? Okay, Redis pub sub, and it's gonna be more in memory, so it's gonna be lighter weight than using Kafka topics. I see. Kind of makes sense. What do we do with users? What do we do to handle multiple clients for a given user? I mean, multiple clients for a given user. I think we could kind of treat every client as a separate user. So what do we do? Yeah, we can kind of, like, our data model kind of already handles that. We have users and clients. Users could contain multiple clients. So we could kind of treat all of those as separate, each client, we can treat each client as separate users. And yeah, just deliver it the same way that we would usually do. Imagine. Yeah, they'll ask in all the SF companies, they'll definitely ask system design. I even got asked system design question coming in as a new grad. They're gonna ask system design. I don't know about the other companies, but definitely in the Bay Area for mid level, they do system design. And system design, even for meta, they ask system design for mid level. But system design is how they figure out if they're gonna give you a senior role or a mid level role. So usually for mid level, they're gonna ask that. Yeah, you'll pick up quick, man. You're smart. And you're already doing a master's and stuff. Are you taking any distributed systems or distributed algos courses? Yeah, we already have our clients database. Bro, yeah, just if you're doing ML stuff, just get straight into like quant, bro. Like, you can't be cracked at math and not pursue quant. I feel like since you're already there, just pursue quant. What? Okay, yeah. So Puberon, that's a really good book. I've read that book. Where did you go for undergrad? Your undergrad wasn't trash, bro. Okay, we're done. Ooh, that was a lot. We're 2 hours in. What's the school? Top 200 state school? I think, bro, I went to a random school too. But yeah, I think quant is way more, like, they really care about your school. University of Louisville? I think I know that team. Like, they have a good basketball team. Oh yeah, Louisville Cardinals. Yeah, they're pretty elitist. Not gonna lie, you're right. Okay. So I'm gonna brush up on data modeling in both. Tomorrow I'll do this SQL. Yeah, as you get more experience, it starts to matter less. Like I didn't go to any school here in the U.S. I went to one in Canada, and it's not really that known. So, and I have other friends too who did the same thing, and they're working at like really good companies, like autonomous driving companies like Waymo and stuff, LinkedIn, Google, um, all from my school. So it's still possible. Yeah, yeah. Okay, let's do some. Okay, now I think we got through. This was our whole. Now we designed a chat system. I probably won't get into design Facebook Live. Maybe I'll do that tomorrow. Or design. This was design Facebook Messenger. And let's just do a couple leak code questions to round out the day. And then I'm gonna go watch some Severance. So we have designed Facebook newsfeed. We have designed Facebook Messenger. That was pretty fun. I need to brush up on my modeling for SQL and NoSQL, especially if I'm focused on more product. And bro, I just started watching it. I'm only on season 1, episode 1, but I'm gonna brush up on data modeling, and I'm gonna look up Bloom filters too. Okay, let's just like brush up a little bit on some leak code. I have some questions that I wrote down that I wanted to get at. Yo, this one video that I had with this Amazon engineer is doing good right now. People like this one. Yo, who saw it? He asked me like count and say or something. Yeah, it's like run length encoding. I have some questions that I want to handle real quick. Yeah, I was trying to seek a different runtime too. But I think that's why it's important to, when you're talking to your interviewer, to figure out, like when you're talking to the interviewer, try to figure out if you can do it faster or not. I feel like if you just keep checking with your interviewer, be like, okay, is this runtime okay? If he's like, can it be optimized? Then you keep looking. But if, like, you're gonna like look at the reaction of the interviewer to see, pretty much see if it's fast enough or not. I don't. Yeah, Paul, bro, it's not really 2 to the n because it doesn't just grow by 2 every time, but it's like 4 to the n divided by 3 or something. But like that equation is just like messed up. The hell is H index? Given an array given an array of integer citations where citations I is the number of citations a researcher received for their ith paper, return the researcher's H index. According to the maximum value of H such that the given researcher has published at least H papers that have been cited at least H times. So this one has 3 papers that have been cited at least 3 times. I feel like this is some modified binary search. Alpha code. I feel like constraints is mostly just LeetCode specific, because LeetCode, they want you to they add a bunch of constraints because they don't want that code to run way too long and like use up all their resources. So they add constraints. In a real interview, the constraints usually are different. Usually they're not like 1 to n, but mostly they'll be like, is this thing well formatted or not well formatted? Stuff like that. So I think we could just binary search, and that will be, we can binary search. We can be like, we can look at, that would be like n times log the values here, m. So n equals size of array, m equals number of values to search. Is that the fastest we can do though? Would be that would be one way. Could we do that faster? Maybe we can do this in one pass. What if we did a sorting? What if we sorted it 6, 5, 3, 1, 0. So we'll say the maximum value of H such that has published at least H. So if we're at 6, or let's do this. 0, 1, 3, 5, 6. So what's the values here? What is the value? Citations is between 0 to 100. So I guess the most here is n to log 1000. So it's still since we're constrained here, it's actually pretty much O of n. So I think the binary search would actually work here, right? Because it's kind of constrained. Or we could have n times log to 1000, worst case. Or could we do straight n? So what if we do 0 or 0? We have a possible H, right? Do 0. If we have 1, so possible H, 1 will work, right? Or we could just probably binary search actually on here. We could probably just binary search. Yeah, we can binary search here, but we need to sort it. And I mean, that'll be n log n. But essentially what we can do is I mean, we could do n log n it and then pretty much search. Can we do 3? 3? Yeah, because here and we have at least 3 elements left. And we know we can try over here. Yeah, but the thing is, per baron, we have to do a sort. So the sort is n log n. Is n log n, and n is larger than 5, can be 5,000, right? Take third from last element. Ben, but like sorting is n log n, and n could be 5,000. I think if we do n, if we just do binary search based on the values, so we could if we binary search for the h index, it will be faster because the h index could only be between 0 and 1,000. So let's just do that. Let's see, count. Okay. So count num So we're doing for element in citations, right? If the target, if the element is greater than equal to the target, we're gonna do result plus equals to 1. If the result is greater than or equal to the target, we're gonna return true. So if the citations, if we're gonna look through the citation, if the citations is greater than the target, pretend it's 3, we're gonna increase that by 1. If the result suddenly gets over to 3, we're gonna return true. So we're gonna do just a simple binary search. We're gonna start left and right. Yo, Paul, I'm gonna instead of binary searching, I'm gonna binary search based on h index, because that's gonna be as at most n log k. That's gonna be faster than if we sort, because yeah, we can sort too, but that's n log n. I guess there's like 2 approaches here. Pretty much, if n, depending on the n, right? If n is under 1,000. We should probably sort. If n is greater than 1,000, we could just binary search based on the values. Pretty sure you could just do O of n here and what? Use extra space. Okay, what are you gonna do for O of n? I mean, we could count the number. Yeah, I think let me try doing let's just try doing this binary searching for h index. because that also works too. And then maybe we could figure out left plus right minus 2, and we get the mid if count num cited of, we'll pass in our citations, and then we'll also pass in our target. If it actually has that, we'll say best yeah, mine's n log k with no extra space. Alpha, what are you thinking for this solution? Would you binary search based on the h index? Would you do a sort? So best equals if best, we'll do that. So what is the best? The best is equal to the max. And then we're gonna say if we could actually get that much cited, we'll do left. Because we're gonna want to look for higher indexes. Otherwise, we're gonna look for lower indexes. Nice. Okay, let's look at the solution. Sorting. Counting. What? Okay. They did the counting sort like you mentioned. Oh wow, that's a way smarter solution. So we just how come people don't binary search? Oh, and then okay, I don't even get the bucket sort solution. What are you even talking about? Let's just look at the solution. However, in our problem, the keys are the citations of each paper, which can be larger than the number of papers. It seems that we cannot use counting sort. Or do we store like a prefix sum? I need to look at this. Okay, let's do a different one. Insert. I'm already cooked. Probably do a couple more, and then we're gonna watch some Severance. Yo, Alpha, what's your rank? Can you? Well, we're just searching. We're just searching for. We're basically trying to binary search for the H index. So, holy crap, that's crazy, bro. So, pretend. Let's see. Pretend we're gonna try to see if the H index is 2. Well, look. Yes, it's 2 works. That's basically we're basically checking if it's possible here. Did it work? Yes. And then we'll try to look for higher values, right? Yeah, you're right. But Ben, does that make sense? We're basically just binary searching for the specific H index, and like pretend if an H index works, we're going to try to look for H index higher than it. If it doesn't work, we're going to try to look for H index lower to it. So we should be able to find, that should be an n times log k algorithm, because we're gonna run this log k times, and each time it's going to be n. I need to reread that solution, but I'm too cooked to be looking at solutions right now. Flatten the tree into a linked list. Linked list should use the same tree node class for the. What? So, flatten the tree into a linked list. The linked list should use the same tree node class where the right child pointer points to the next node in the list, and the left so I think we just need to do a pre-order traversal. Why do they only have one? Bro. I mean, the most basic approach is just do a pre-order traversal to build the list, and then just point them to each other. But what we can do is also pass, when we do the pre-order traversal, we can do like a post order. So we do left, right. But which one do we want to visit first? We want to visit our right. We just need the last one we're on. Yeah. All we need to do is keep track of our current node and our previous node. Yeah, we just need to, let's just do this. Okay, yeah, you're right. What was he? This one we kind of had to draw out. So let's try a pre-order traversal. We do 1. We keep our first and last. We go left. We say 1. Next pointer is equal to. Well, because actually it'll work because when we go left, right? We'll say 1.next is equal, or would that work? Maybe we'll need to do a post order. Or no, what we can do is because we'll eventually want to go right. But let's cancel this out. So I think this will be 1, 2. This should be like this, I think. This question's kind of like, at least give us a better example. So, left. So we're going to do this recursively. So yeah, since we already visited the left, we can just be like 1. We could say 1.left pointer is actually, yeah, we can make this point to, but it's already pointing to this one. Then when we go to right pointer, yeah. Yeah, Shabaj, I'm trying to do it in one pass. I think if we just assign to the left pointer, so we keep track of our previous, and then we keep track of our current. So current is equal to 1, and then when we go here, we do our current is equal to 2. We say 1 links to 2, right? And then when we recurse, before we go into the right node, what we're gonna do is when we go into the right node, eventually this is gonna be 2, and this is gonna be 5. What we're gonna do is we're gonna then when we get back to a node, maybe it's like an in order traversal. Or no, we could just do a pre-order. Yeah, we'll do a pre-order because so we visit them. But essentially, when we go into 5, this is we're gonna 1 is still gonna link to 5 here, right? But what we're gonna do is we're essentially gonna link 2 to 5, right? And then what we're gonna go, and then we're just gonna delete a but we're gonna say 2.left. So these are the left pointers, and then we're essentially gonna move all the left pointers to the right pointers. Dude, that's gonna be trippy. But when we get to 5 here, what are we gonna do? 5 is gonna have like a right pointer to 6. So 5 is gonna get pushed over here. And the current node is gonna be 6. Then we'll say 5 dot left is equal to 6, like that. Then after, we just need to delete all of these right pointers. Does that work? Like, after, we just need to switch our left pointers to our right pointers. I think that might work, but that's kind of confusing. Yo, Alpha, are you coding on the side too? Do one. Yeah, that's the easy solution, but I doubt any company is gonna let you. I doubt, like, Meta likes to ask one for like convert this binary search tree into a W linked list, and they'll never let you just do it that way. Yeah, we're gonna do pre-order traversals. Yeah, I heard that same thing. Or so what we're gonna do is, what did we say we're gonna do? We're gonna say, we're gonna do this pre-order traversal. We're gonna say if self dot previous exists. We do self dot previous dot next equals self dot current or the current node. Then what we're gonna do is, nah, not really. We're gonna do, I don't know Golang. How is it? Node left, node right. And what we're gonna do is so it's gonna be yeah, it needs to be a pre-order. Okay. Dot left. So we're gonna self dot previous dot left is gonna be equal to that node, so we don't lose that connection. And then Yeah, Alpha Code, you go crazy, bro. You're learning a lot. You can do this in one pass? But did you do it in doubly linked list of a binary search tree? That's different, I think. Yeah, binary the binary search tree, I know how to do that one. I think this one you might not be able to just you need to update the pointers at the end. Alpha, bro, some companies will ask you. It's some companies actually will just be like you have to do it in one pass and it's so annoying, but I'm that in that same boat of like why would we care, but I don't even know, some companies care. For this question specifically, Sabaj, or I know you can do it for the other one. Okay, let me try my approach quick. Every work. Holy crap! That actually just worked off the gate, bro. The amount of linked list questions that I done. Okay. Um. Okay, let me figure out how to do it in one pass as well. Because I think when you pass it down, I think. I mean, I think all we need to do is before we do right, we just do this temp equals node dot right. Node dot right equals. Can you actually do this in one pass? Wait, let's see if let's see if it shows up here. Bro, Morse traversal is so annoying. Who actually knows the Morse traversal? Okay, how do we do this in one pass? I don't know if I want to do that. I mean, okay, I gotta read that tomorrow. How'd you do it in one pass? Could you coach me on here real quick? So if we do, did you do a pre-order, or just give me a hint? Did you do a pre-order, post-order, or Shabaj? Like, what did you still do a pre-order or a post-order, or in order? I think as long as I know what kind of traversal you did, I can figure something out. You solved the left subtree. So you did a post order, then I saw. Okay. Oh, okay. Temp equals no dot right. And then what we do is just go like this. Wait, okay. So 1. Wait, isn't this what I did just right here? Is this you? What did I do wrong? My code looks the same, bro. Okay, link is wrong. Okay, let me refresh this. Well, I see. Okay, no. I see what. Oh, I have to click into your thing. I have to click here. I see what you're saying here. Oh, I see. Does the ordering matter here? Shit. I see. Damn. Okay, I gotta read up on that. Yo, have y'all done this one? Multiply strings? Kind of annoying. Or I did it in a different way before. I had a different approach before. My initial approach was like this. Yeah, I was switching it. But now... Yeah, now we just need to do... Now we just set it. But we need to store it so we can traverse it. Okay, that makes sense. So 1 points to 2. Yeah, I see how that works. Bro, what is this Morris? Have y'all done this? Multiply. Bro, say swear you code on the Windows. Oh no, Paul said he hates Macs. I like Mac too, I'm not gonna lie. Really? You hate the Apple UI? That's a first. Yo, have y'all solved this in O of n time? Or have y'all done this in O of 1 space? The algorithm here for O of 1 space is pretty interesting. Oh yeah. Yo, Paul, did you say that everyone got in trouble for using this optimal solution? For using this one? What's the tournament algo? Nah, it's facts. Yeah, before you had to like grind looking at Chegg and stuff. Interesting. Shit, okay. Interesting. That's an interesting solution. Let's see. Alright, the stream hit 3 hours now. I'm gonna catch y'all in the next stream. Thanks for tuning in. Hit a lot of good system design. Probably do some system design next time as well. But yo, Squagmire, appreciate you, bro. But I'll catch y'all in the next stream. Limited to like 3 hours today, so I get some. I'm gonna go watch what is it called? Severance. So I need to clock out a little early today. I mean, it's already 11, but good night. Good night, fam. Nice to see y'all. Catch y'all in the next stream. Thanks for tuning in, like always. Yeah, you got this, Alpha. Good stuff. I'm excited to see your content. Catch y'all.